Hey, welcome back to Learning to Program using the Godot game programming engine. Alright, this is the second take. First one I sounded like I was about to fall asleep, so I went and got some caffeine and some chocolate, so hopefully this one will be a little bit more entertaining. Alright, so now that we've passed the Christmas holiday and we're about to start class back up, I thought this would be a fantastic time to review all of the programming fundamentals. So I thought to myself, what are the basics that I would want someone to learn and know if they were going to say, this is what programming is? So I thought about it long and hard, and I remembered there's this fella named Alan Turing who came up with this concept of Turing completeness. And it has something to do with being able to talk to a computer and the computer be able to talk back to you and not know that it's a computer versus a person. And that's the long of it. But the short of it is to show that something is Turing complete, and this is the wiki. It's enough that you can saying that you can make a Turing complete system, excuse me. And to do that, what you need is conditional branching and the ability to change an arbitrary amount of memory. So those are kind of the two big breakdowns of what computer programming needs. And so I kind of broke that down and I rewrote these as memory manipulation, so that's being able to change memory, and then conditional branching. I like that so we just went with that straight from the wiki. So I've reordered these because this is kind of the way we covered it in class a little bit. Let's see, so we've got these two breakdowns, and within here we've got variables and being able to manipulate them in different ways, and then arrays, which we haven't talked a whole lot about but are super important to computer programming because it's a real basic data structure. Alright, then we've got conditional branching, and the three big things here that I broke down that I thought were super important is conditional statements, specifically the if and else statements, functions, the func statement, and then loops, and specifically the for loop. So there's a bunch of loops in Godot and other languages, but the for statement is real important in Godot. Alright, so let's jump right into some examples and see how this works in Godot. Alright, so I've got this little test project set up here, and it doesn't do anything except it's got a blank screen, and all it does is run this code. Alright, so the code right here, it runs two functions, the variable examples and the conditional branching examples. Alright, so we're going to look at both of these, and let's just start right in with the variable examples. So this is how you create and initialize a variable. Right, so you just say var, and then you give it a name, and then you have the equal sign and the value that you want to give it. And of course, remember, these are comments, so anything after the hashtag does not count as code. It's just for the developer. So here I'm just kind of explaining what's going on. Alright, so here's a Boolean, right? And we know that because we're setting it to a true statement. So in other languages you may define it like bool, my bool 1, right, equals some value. But in Godot we don't do that, we just give it the var. And this is called duck typing, which means if it quacks like a duck and it looks like a duck, it's probably a duck. So in this case, because it looks like a Boolean, because I put a true or false value in there, it's assigning it and making it a Boolean value. Alright, so here's a couple examples of how to use them. So here I'm assigning a true or false, so this is always going to be true because out of those two values the true is always true. And here I'm using an integer comparison, right? So I'm using that comparator operator right there. There's also the greater than, less than, etc. And this returns a Boolean value. You can also do that on words, right? So you can do these two letters or strings match, and if they do, then it's true, and if they don't, then it's false. And here we're reading another value and using that in a Boolean expression. So I'm saying if bool 1 or bool 3, so if either one of those two are true, then bool 4 will then be true. Alright? So that's kind of a rundown of how we're going to look at all these different types of variables. So let's move on to integers or whole numbers. So these can also be positive or negative. I didn't represent any negative numbers here, but both integer and floating point can be negative, right? So a whole number just means there's no numbers after the, like if there was a period, there's no numbers after the period here. So it's a whole number, like 1, 2, 3, there's no 1.5 or anything like that. So that's an integer. And so we can do basic math on that. I like to think of this as like calculator math. This is the kind of stuff a calculator could do. You can add numbers, you can multiply, you can divide, so on and so forth. And we can also use another variable as part of that calculator math. All right. Floating point, same deal. The difference is floating point stands for this period can float around in this number, right? So this is also a floating point, so I could say var f2 equals, and you could have 0.00001, that's also a floating point. You could also make it 1.0000001, that's also a floating point. Even 1.0 is a floating point because I've defined that period in there. Alright, so if I left that out and just did 1, that's not a floating point, that's an integer. But as soon as I add that 0.0, that's now a floating point. Alright? So the one difference here is I have an example of combining an integer with a floating point. And so in this case, the result will always promote up to a floating point. So an integer is a smaller amount of data in the memory of the computer, and a floating point is bigger because it has to hold that floating point and all this numbers after it. So floating point soaks up a little bit more memory in your computer, so they're a little bit less efficient, I guess you could say. But when you combine it with an integer, it has to promote it up to a floating point. So that's just something to be aware of, that's how that works, but it can be done, right? So if you want to multiply, if I wanted to multiply this number by 2, I can do that. I just say my float 1 times 2, and then that will be a resulting floating point number. All right. So then let's look at string manipulation. So we've got strings. So here's how you define a string. And both in Godot, both single and, so if I said var my string 1b, let's put it down below, equals hello world, that's the same thing as above. And you notice my quotes are a little bit different there. These are double quotes and these are single quotes, but they're both the same to Godot. But you do have to make sure you match. So if I put single at the front and then double at the end, that would not stop my string, right? So it just converted all of this into a string because it doesn't know to stop it. But as soon as I hit that single quote, now stops it, and you notice my double quote is part of that string. So that's how you get, if you need a single quote or double quote in there, you can do that. I think you can also use the slash and then the quote like that. I think that would also work, and it would just count as a double quote there. But anyways, that's how that works. So just remember that the single and double are interchangeable for strings. So we have string concatenation. So it's kind of like addition, but the difference here is we're just kind of like sticking them together, right? And that's what the word concatenation means, is you're just sticking these strings together. And in this example, we're sticking this string onto this string, but this one is a variable, so it's pulling hello world up here and then sticking this says Mr. Michael onto that, right? And here is kind of a little bit of a complicated example. Let's move these print statements down here. Right. So, oops. Yeah. So what this does is we're using this find method off from string to find the first occurrence of this string. So it's going to look through hello world, and it's going to stop as soon as it finds that, and it's going to return the number, the index of that string of this. And a string is kind of like an array, and we'll look at arrays in a second. And they start with 0, so it's going to return 0, 1, 2, 3, 4, 5, 6. So it's going to return the number 6 for that. And we'll see this when we run it. Right there is actually the number that we're printing right here for that start world. And then here we're getting the length of the string, so I can say for the word world, how long is that, right? And that will also return an integer, just like the index the find statement did. And then the third one that's commonly used together with these two is the substring. What the substring does is it allows you to return a part of a word. So if you could return just LLO, right? And what we're doing is we're using those two indexes that we got before, the index for the start of world and the length of world, and we're using those two values to pick out just that part of the string. So in this case, my string 4 is printing just world. So that's a real common thing to use together, or tools to use together as part of strings. There's other string manipulation functions, but the one you use the most common by far is the concatenating, being able to stick them together. And sometimes you'll use this substring. An example that is probably more common is, let's say somebody sends you a string that has a bunch of, so v, and they have 5, 3, 7, or 9, whatever, 10, right? And you want to return, maybe you wanted to add all these numbers up, right? But this is in a string, so in order to get these numbers out, what you would need to do is use that find statement and say find the first comma, and then substring off that first bit up to the comma, right? And then convert that into a number, and then you could add that together. So that's actually a pretty complicated problem to do right there, but that's how you would do it, is you'd use these tools to do that. Alright, so next up is conversion. So this is the first case where we really were worried about converting. So over here you can also convert floats back down into integers, and you just lose this about the exponent there, or excuse me, the part after the period. And I think if you just convert, I believe it doesn't round, it just chops it off. There are math rounding functions that you can use. Shouldn't get on this rabbit trail, but I'm bad about that. So no, I'm looking under this. Is what I need to be looking under. GD script round, yeah. All right, so it returns the integral value nearest to s, and the s is the value you're pointing in. So here's the example is 2.6, and you round that and you get 3. So there's a way to round in GD script. In this case it would round down because 0.14 is less than 5, so it would round down anyways to just 3. Alright, so yeah, but in this case we're taking a floating point number, which was 3.141592, and we're converting it into a string so that we can concatenate it together with this pi equals. And that will print this guy right there, right? So if we tried to print it without this conversion, that would give us an error, because it'd be like, I can't stick together a number and a string together. That's not right. Some languages can do that automatically, but I actually don't mind that it's explicit here, meaning it makes you do this, because it kind of makes you program things correctly, and very intentional, right? Alright, so let's look at arrays. So arrays are something we haven't looked a whole lot at, I don't think, in this series, but they're super important. They're a very basic programming structure, and all it is a bunch of other types of values that are stuck in a list together. Alright? So in this case I'm doing an array of strings, right? Because those are strings, but these could be anything. I could put numbers, I could put strings, I could put floating points, I could also put other arrays inside of here. Alright, I could also put nodes in there, and that's something I probably should add in here, but we'll look at that in a second. So arrays are 0 indexed. So here's a kind of like little hint. This is index 0, this is index 1, and this is index 2. So what we can do with arrays is we can do assignment. So I can say at index 0, and you use this little bracket sign to manipulate arrays. So you say at index 0, set that to z. So that would override this a with a z. And then here I'm getting the value, so you use those same brackets with the number to pull the value out. So in this case I'm getting index 2, which is the c, and so that c will be pulled back and stored into my string 6. And notice it's a string and not a array because I'm just pulling out that one element right there. Alright? And then there's two methods for adding and removing things. So I've got append, which just sticks it on the end, so D would get stuck on the end, and remove takes the index, so it wants to know which element do you want to remove, and in this case I'm removing 1, so this B will get removed right there. And finally I can print the array, so if we look down here, arrays get printed and they look like this. So remember, we replaced the A, we removed the B, and then we added the D after the C. So that's how arrays work, and it's pretty simple, not too bad, and they're super duper useful, and hopefully we'll have an example of this later. Well, actually a good example of this is if you did a tic-tac-toe board or a chess board. A lot of times you'll use an array to store that. Alright, so the one thing I didn't mention here, probably should add, is a node type. So my, or actually it's an object. My object 1 equals get node main. Alright, so in this case it'll actually fail. I probably should add one here, so let's add a sprite. Alright, and I'm not going to do anything with that, I'm just going to say sprite. And so it needs to match that name right there, right? Of course, because this is Godot, and we're looking in for child nodes that match that name. So there's sprite. All right. So sprite is a sprite class. So see right there, it says type sprite, and sprite is a class. So if we come up here and click on classes and we do sprite, all right, class sprite. Alright, so that's what that means. And all these classes are objects. And an object is it's part of a bigger concept called object-oriented programming, and we're not going to worry about that right now. But all it means is all these things are available to you all from that object. So, for instance, texture. So let's look at that real quick. So we've got my object 1. So I could say my object 1.texture equals, and I could give it a resource here. So I could say this icon, right? So I could say load, and then say this icon, right? So now if I run this, I should actually see that image load up there in the corner at 0, 0. There's another property called object1.position, right? And that's a vector 2. And let's set it to like 100, 100. So that should move it out somewhere in the middle of our page. Right there. So, and the way I found that was, if I'm looking at my code and I look up classes and I look up sprite, you can see that sprite inherits from these other things, right? And this is that object-oriented programming. And you don't need to worry about it too much, but all these things are available to you, as well as the things from all of these up here in this chain. So specifically, if I look at this node 2D, I have this position vector, and it's a vector 2. So that's how I knew that I would have access to this position. Alright, so anyways, that's an object, and these can also be stored in arrays. So you could have an array of nodes, right? Alright, so moving on, that's let's add a comment real quick here, just so we know this is an object type. Alright, so here is conditional branching examples. So this should be real easy. We've covered if statements out the wazoo, and if statements are super simple. All they do is they determine if this condition right here, and it uses Boolean logic, is true, then this code works. This code runs. Otherwise, it's completely ignored. So in this case, I'm just doing a real simple statement here and assigning it to true so that we can see it in action here, because what we're really interested in is the if statement. We don't particularly care about this because we learned about that up above. So you can use all these things up here, specifically in this Boolean expressions, right? You can use all that combined with these things, so you could concatenate strings together and then compare them to see if they're equal in order to create your Boolean expression. But these are your expressions up here, and what we really are interested in is the if statement. So if this condition is true, then we do this code. So I like to think of this as, a person is walking down a trail, say in the woods, and the path forks. Which path do they take? Usually there's some information there, or the person has a goal in mind. They want to get, to the waterfall. So they would look at the sign, and the sign may say this way, go right to the waterfall. And they say, I want to go to the waterfall. So they say, the condition would be waterfall is my goal, and the right is waterfall, so therefore I want to go to the right. So anyways, that's what the if statement's for. And we also have the else statement, which combines with it, and it does the same thing, except it only runs the code when the condition is false. So here in this case, I can say if this is true, I can run this code, and if it's false, I can run this code. And that's about it for if statements. So that's super easy and basic and very, very, very important. Alright? Then there's loops. So we're going to focus on the for loop because in Godot it is extremely powerful. This same statement can be used both for counting over a range of numbers, but also for looping over an array. So we'll look at both of these examples, but the first one, this is probably the most common one that you want to do, is you'll have some range. And in this case, I'm just saying from 0 to 10, but you could also say, if you had the string, say like word, remember before we had the length of word? We could take this right here and put that in here. So for 0 to the length of word, run this print I. Alright? So if I run this, and I close it, and you come down here, the word world is 5 characters long, so I've run 1, 2, 3, 4, 5 times. Alright? So if I put 10 in here, it should run 10 times. So it runs from 0 to 9, so it ran 10 times. So this is a good example of a for statement, and this is super basic, and we do this all the time in programming. Now this is a more complicated example, but don't let it get you too worked up. It's not actually that complicated. What we're doing is we're looping the same for loop, except instead of looping over a range, we're just looping over an array. And here's my array, and it's got a bunch of strings in it, right? Or letters. So what I'm doing here, this is pretty common, is when you loop over a set of things, is you want to do something, you want to somehow combine that data. So maybe you want to find the sum of a bunch of numbers, right? You might do this very same thing. You would have, here's your, your accumulator or your sum, and as you loop over it, you want to add that together, right? So I'm doing the same thing here. I'm just using concatenation to push all these single letters together into one big string, and then I'm printing it. And so if you look down here, I'm printing hello world, all as one string. All right? So that's the looping over an array. All right? So that's all good. And finally, functions. So functions are very simple. We've been using them here for our ready function and our example functions, but here I've got one called my test function, and all it does is print this string and adds on the parameter that we're passing in. And here I'm passing it in, I'm just calling it once, calling my function once, and I'm passing in a string called programming fundamentals. And that prints out right here, this is a function, and you pass the value programming fundamentals. Alright? Then here we're doing the same, we're calling the same function, but we're using it inside of a loop. So now we can call it 3 times by just one line of code. Right? And I could change this to 100 if I wanted to. Why not? Computers are super fast. There, it's already done. It printed all 100 of them, and here Godot said, "Oh, you're printing this a whole lot in one line, so I'm gonna stop printing it." Right? So, but it did print and it did work right there. So here's a smaller number that Godot's not gonna stop printing them on. Now it did run before when I did 100. It did run. So if I had done some math or something or impacted my scene in there, it would have run all 100 of them. Godot just blocks your output from spamming too much because generally wouldn't be very helpful to have too much data down here. Alright, so anyways, this is a real common thing. Maybe you have your menu, right? So your menu here is you can push some buttons for, oh, I want to start my game, I want to delete my game, whatever. And you want to do that until the player is done, or also the main loop of the game is actually in a loop, right? And it just loops forever until the player hits the escape button. Alright, so anyways, this is functions, and I hope that this wasn't too confusing. The one thing I did want to point out specifically was remember indentation. It's super important in Godot. Now it's not just tabs, right? So spaces count too. So I could actually make a function here called, we'll just call it B, and instead of a tab I'm going to use 2 spaces. That's perfectly valid, but I need to make sure that my next line is also two spaces. Alright, if I just did 1 and put a statement here, that's no longer valid because it's not the same. See, indent does not match. It's not the same number of indentation. So instead of using spaces, I would really advise using these tabs, which show these special characters right there, because they're that's what they're designed for, and they just work much better. Alright, so make sure you use, whenever you start a block, which is usually in Godot signified by a colon at the end of your line, make sure you use indentation afterwards to make sure you execute the right amount of code for that function or loop or if statement. Alright, so if statements have that colon as well. Alright, so that's the basic programming fundamentals. If you walk away from this series or class and these are the things, and you understand these basics, I would be extremely thrilled. There are a couple more bonus things that I kind of wanted to talk about specifically for Godot. So if you're programming in Godot, you're going to have a hard time avoiding these things. So the one is object-oriented programming, which we talked briefly about when we mentioned the object type variables here, right? So classes are hard to avoid just because Godot is built heavily on these classes and this inheritance. So that's what this is called when, so if you look here, this spatial node inherits from node, which inherits from object. So if I extended that spatial node, I would get all the things from that spatial node that are provided there, right? So I get all this stuff, but I also get all the things from node. So I have this pause mode and name, etc. But I also get all the things from object, so I get all these things too. So that's what inheritance, that's kind of the super basics of inheritance. But the big thing we need to worry about, or that you should understand, is when I extend a class, or I get a class using this get node, excuse me for jumping around, hope I'm not making too many people dizzy. When I do this get node, if you look up that class of that type, so say sprite, if I go back to my code and I look up the class sprite, these things are available to me as after the period, right? So like that texture and the position, those things are available to me from that class. Alright, so that's kind of the basics of object-oriented programming and classes. We'll talk more about inheritance, so intentionally doing this, this kind of inheritance of this nesting, doing that intentionally on our own. We'll look at that in the future, but for now, just know that objects are out there, and we need to use them for things like this, where we're getting the sprite and we're setting the texture to it. Alright? And we do the same thing, we may play a sound, we need to call the play function off from a sound file, so on and so forth. Alright, so the other thing is signals. So signals are super important, and they're important for multiple reasons. The primary being they're just easier to use. So if we have a button, right, and let's say I put a button out here on my screen, and I've got a button, right, and I want to do some code when that button is clicked. Well, I could come in here to my script, and up here in I could make a process function, right? So I've got my process function, and in my process function I could write a whole bunch of code to try and figure out where the mouse is when the mouse button is pressed, the left mouse button is pressed, and to make sure that it's inside this box of the bounds of this button, right? So that's a lot of work, right? And it would have to run every single frame of the game because it's here in this process method. However, by using signals, all I have to do is attach to that button. I can say, hey, on the pressed event, I want you to go ahead and run this code. So it creates a function for me, and this code right here will only run when that button is clicked. So not only is it quicker to set up, it's much quicker to set up, it also is much more efficient because it's only running this code in that one case of that button being pressed. So for instance, we'll just make sure this works. Button pressed with 3 exclamation points because that's how important this is. There's our button pressed. Alright? So signals are super important, and they're super hard to avoid in Godot because they're so powerful and they're so useful. So those are the 2 big things. We've got the buttons, the signals and the classes, and that's the basics or fundamentals of programming in Godot. So I hope you learned something from this video. If not, or if you have questions, please ask them in the comments. Also, if something was a little fuzzy to you, you could review the video, because all of these concepts are super important to programming, and specifically in Godot. So I'll thank you for watching, and I'll talk to you next time.